So we see on one hand the possibilities of AI for pathology, but also we see that the biggest hurdle for everyone in the field, not just for academics, but also for pharma research and for companies, small companies, large companies, is really the lack of good quality data and associated metadata. So we realized that AI can play a big role, and it says here we will be able to get better knowledge of diseases by studying all kinds of disease tissue sections. It can lead to better treatments. It can improve our diagnostic accuracy, efficiency, and especially, of course, in the tox path world, it can help to replace, reduce, and refine animal research. But we realized to really be able to develop meaningful applications, we need lots of data. So that's why we started to set a big picture.
Learn about the newest digital pathology trends in science and industry, meet the most interesting people in the niche, and gain insights relevant to your own projects. Here is where pathology meets computer science. You are listening to the Digital Pathology Podcast with your host, Dr. Alexandra Zhurov.
Welcome everyone, Big Picture. So if you're working in drug development or are even remotely interested in digital pathology and tissue image analysis and know that you need a lot of data for deep learning, you've probably heard this initiative, Big Picture. Everybody's talking about collecting images for developing generalizable algorithms that can help accelerate drug development and improve healthcare, in general, patient care as well. A big initiative, and if you're not part of it, you probably heard of it, peripherally know what this initiative is about, that it's going on, and it's called Big Pictures. So there's going to be many pictures, pathology slides. This is why the project is called like that. But for those not directly involved, we meet here today with two of the projects that are here with me. Welcome. I have Jeroen van der Laak here and Julie Boisclair. Jeroen is a full professor at Radboud University in the Netherlands, and he is also the co-organizer of the famous Chameleon Challenges, image analysis challenges for detecting breast cancer metastasis in lymph nodes. And Julie Boisclair, she's a veterinary pathologist, as myself, and she has over 20 years of experience both in CROs and pharma in the non-clinical part of drug development. And she is leading the non-clinical part of digital pathology and computational pathology efforts at Novartis. Welcome, both of you. I'm super happy to have you here today.
Thank you, Alexandra. Thanks for inviting us.
Thank you.
So I hope my intro to the Big Picture initiative was not too confusing, but even if it was, we're going to talk about what that is. We're going to answer the question, what is it? Why is it even organized? Who's doing it? And how are you guys doing it? It's a long-term initiative. Once we cover the basics, the what, why, and who, we're going to talk about what has already been done. So without further ado, I leave the stage to you. So Jeroen, before we dive into the big picture, do you want to say a couple more words about yourself?
Sure, yeah. Thanks, Alexandra. Yes, so my name is Jeroen van der Laak, and as you said, I'm a professor of computational pathology in the Netherlands, Radboud University Medical Center. I am also a guest professor in Linköping in Sweden, and I am the CSO of a spin-off company, Aimsin. Actually, I'm not a pathologist like you guys. I'm a computer scientist. I studied computer science, and I have been working in the pathology department for close to 30 years now, so a long time. And all this time I have been developing.
You've put up with pathologists for 30 years?
Yeah, it's amazing, isn't it?
That is an achievement in itself.
I should put this on my CV, I think, yes. My research is really on the development of computerized analysis methods of software for histopathology, which used to be a niche thing, but in the last, say, 10 years, now we have whole site imaging and we have modern AI technology. It's really become a mainstream thing in pathology. What we realized more and more actually is that, yeah, as you said, to be able to do this and to develop AI for pathology, we need lots of data, and that's where Big Picture comes in.
Okay, thank you, Jeroen, for the intro. And yeah, 30 years in pathology department is a huge achievement. Julie, a couple of words about yourself from yourself.
I'm Canadian. I now live in Switzerland and work for Novartis in Switzerland. I've worked in several places on the planet, so Canada, US, and also in Europe. And
Same here.
I was always an early adopter of new technologies, including digital pathology. So I've been using digital pathology since several years, probably since its infancy 15 years ago or so. So I remember starting in Novartis and already playing with digital images. But at that time, we were not as ambitious as we are now. So those images were used for very specific use case. And now we are seeing this as a really a way to completely revolutionize the way we will perform pathology in the future and improve our life, being more efficient, for example, being better also. This way, we really see that as a kind of help for the pathologist. That's why I've been defending this project so ferociously since its beginning, and that's why I wanted to be involved as well.
So let's start with what is BigPicture?
In a nutshell, so BigPicture is a big repository of all slide images and its metadata. And it's a very big project, 70 million. It's going to include 3 million slides. So 2 million of which will come from the non-clinical node, and 1 million will come from the clinical node. It's going to be very diverse, so different species, a lot of different disease. By doing so, then we are becoming the catalyst for the development of AI models, but having this repository that is open and that is accessible also.
And why did this start? The general why I understand, because everybody wants to develop those algorithms and there's no place to find all those slides. But why now and why in this form that you are doing it?
So the why, I think for me, I found that increasingly we have seen, so we organize, for instance, the Chameleon Challenge, in which we shared 1,400 scan slides with pretty much everyone. And we've seen that over 1,500 research groups downloaded those 1,400 slides. So we noticed there is a huge hunger for data in the digital pathology domain and people working on AI in pathology. And from our own experience, we found that we were increasingly trying to get to collaborations. My time was really, I was spending a lot of time on data transfer agreements and material transfer agreements. And we found that increasingly people needed data and bigger data sets to produce AI and to validate AI for pathology. So we see on one hand the possibilities of AI for pathology, but also we see that the biggest hurdle for everyone in the field, not just for academics, but also for pharma research and for companies, small companies, large companies, is really the lack of good quality data and associated metadata. So we realized that AI can play a big role, and it says here we will be able to get better knowledge of diseases by studying all kinds of disease tissue sections. It can lead to better treatments. It can improve our diagnostic accuracy, efficiency, and especially, of course, in the tox path world, it can help to replace, reduce, and refine animal research. But we realized to really be able to develop meaningful applications, we need lots of data. So that's why we started to set a BigPicture.
And who is doing it? So did you initiate it, Jeroen? Who said we're doing this?
It's basically a combination. The granting scheme that BigPicture is part of, which is called IMI, it's a European Union granting scheme in which principally pharmaceutical companies, together with the European Union, define projects. And let's say they get out a call in which they say, okay, we would like to have people apply for a grant which will do this and this and this. So basically from the pharmaceutical company side, there was a clear need to do this. And we as academics, we saw the call, we read the call, and we realized this was exactly what we were actually thinking about for a long time already. So we wrote a project proposal for this, which was reviewed. There were a number of competing proposals. We won the bid, so to say. After that, the pharmaceutical companies entered, let's say, the consortium, and together we wrote the final text and we developed the project as it is now. So if you say, who is doing this? So basically, At a larger scale, we would like it to be very inclusive. So the community that we aim for is even much broader than the consortium that we're doing. The community could be what you can see here. So pathologists, but also SMEs, governmental organizations, regulatory agencies, researchers, pharma, startup companies. The consortium itself is 46 parties.
Before we go to the consortium, Jeroen, can you go back one slide? Tell me about your logo. Pink thing, I assume these are some nodes of a convolutional neural network, the blue dots, but what's the pink thing? Is this a cell?
It's
a tissue.
Ah, okay.
It's taken a lot of time to get to the logo, Alex, and actually it's not a neural network. It's a connection of different parties in the community. So it's connecting pathologists, companies, in kind of network. But of course, you can see many things in it. And the big thing
I misinterpreted.
We jokingly called pink thing the potato.
It does look like a potato.
The previous version was even more like a potato. It originally was a cell. So the designer that made a cell, and within it was a network. And it was shaped a bit differently now, but it's supposed to be a cell, and it has the H&E color scheme a bit.
Okay. If you are listening on the podcast, then I'm going to put this in the show notes, the picture of the logo. And if you're on YouTube, then you know exactly what we're talking about. Okay. Let's move on then.
So the consortium that is doing the project now is 46 parties, of which 10 are pharmaceutical companies and 36 it's a mix of small, medium enterprises, academic centers, but also smaller hospitals. We have regulatory agencies in it. So it's really a very diverse mix of people because we want to tackle many different aspects of this. So we also have legal involved to look at, let's say, the legal landscape. What can we do with data? What are we allowed to do? It's a very large consortium.
But this list, like the people who are involved in this consortium, is already closed, right? There's no, we would like to join as we missed the initial registration, but we want to join you. That's not an option anymore, right? Or am I wrong?
Yeah, usually it's not an option, but we have heard the interest of several additional partners, and we are exploring to see if this is possible or not. But I don't want to have anyone have their hopes too high, but we are looking into this.
Okay.
But so the consortium is closed in the sense that the people that get funded by the European Union, that's pretty much closed. So it's going to be tough to add partners. But we definitely want to be a very inclusive consortium and community in the future. So any parties that would like to share their data with BigPicture, use data in BigPicture, share AI, build AI on top of BigPicture, everyone is welcome because this is not a 46-party effort in the end. It should be a much bigger effort. So people are really welcome to join this, but will not be able to get funded by the EU because that's closed for now.
The 46 partners are bound for 6 years, and that's where everything starts. But after the 6 years, we have what we call sustainability. So we want this repository not to be functional only for 6 years, but we want it to be functional and even growing with time. So if these partners that have not jumped in the boat early on can jump in the boat later.
Okay, so let's then talk about how are you doing it. You said that it's gonna take 6 years to build this repository, and then after the 6 years, you have a maintenance program for it when actually people can benefit. How are you organizing this? It seems to me a massive project. How are you doing it?
What we would like to do ultimately is to make the data and the AI tools available so they will coexist. And this is through an international and inclusive community of experts. So don't forget that from the beginning, this is a community-based model. So as you have seen us, it's multidisciplinary. We are not coming from the same field, even though Jeroen has coexist 30 years with pathologists. So it's really based on community and sharing. These people are coming from different fields. They are multidisciplinary, and we really want to pave the way for the computational pathology. So why it takes 6 years is to gather 3 million slides, so 4.5 terabytes. It takes time. We need to organize with different type of specialists, and then we need to build a safe repository in which we will be able to put those 3 million slides and their metadata, make sure that the metadata is a very high quality. It is searchable. So when you want to do your AI model, you make sure that you are doing it on the right slides. And so to do so, we are developing also tools that will help the AI develop. Some of these tools, for example, are dichomizer. So we can take slides from any format and put them in a DICOM format. We have annotation tools, viewers, and then we are also discussing with the health authorities to make sure that up to a point, the AI models that will be built and shared on the database and the repository will be accepted by health authorities. So that's how it is built. So there are 6 work packages that we are calling. So these are the 6 group within the IMI BigPicture. So the first one, work package 1, is the management group. So this is the one that Yeun and I are leading. And then there is the one for the repository. There is the node, the clinical node. So these are the pathologists that are gathering all these cases. So these 3 million slides. Very important, deciding also what metadata is important, which one we will include and not include to be able to do those AI models. And then work package 4 is these are the scientists that are doing the different tools and the AI models. There will be 4 use cases that we would like to work on. There will be tumor infiltrating lymphocyte. There is another case that is, I think it's a kidney rejection detection model. Then for non-clinical, we do an outlier detection model, so normal versus abnormal. And also, I think the last one is content-based image retrieval. So these are the 4 cases that the work package 4 will be doing. So to make sure that the repository is of excellent quality so we can test it. And also this will be made available afterwards and can serve as a kind of accelerator for others to share their models also. Work package 5 is the one that is more dealing with the regulatory aspect and the legal aspect and the ethical aspect. And the work package 6 is the one that it will be developing our sustainability model.
So how far are you in the project now?
We are at month 15. So
Years?
it's very early on.
What have you done so far? I assume there is a lot of organizational work going on. So I don't know if you've gone beyond that already, but what have you done in this first year?
The repository was put in place and tested. So there was some pilot that was going on. So the first year is where you build the blocks. And after that, you put the blocks together to make the house, right?
You already have slides, or you have just a place where to put them?
We have a place where to put them, and we have a few test cases that we have put in the pilot with mock data, more or less, but not a huge amount of them.
Okay, so the test cases would be the algorithms or the models?
No, the test cases are just test slides with their metadata.
Okay.
And we have started also to discuss the honest broker aspect. So who's going to be data controller versus contributor? So what's going to be the legal basis? Because as we will have some clinical data in there and also intellectual properties. So it's important that these legal aspects are discussed ahead of time so we make sure that it is protected and it is not available to everyone.
Maybe it's good to add that in Europe, every country has their own rules, of course. So there is a European law, the GDPR, that regulates a lot of issues around personal data, which counts for all of us. But still, every country has their own taste of it. So one, I think, actually quite big effort is done by a legal firm that has looked at what are the differences in different European countries and made a big report, which for me as a computer scientist is tough to read, but It contains a lot of data and a lot of information on what can you do with a scan slide in Belgium versus France, which could be completely different.
Mm-hmm.
So those are things that are not really that sexy, but still it's important that we solve this because in the end, it's needed to be able to share the slides in the end and to know exactly what we can do and what we can't do.
Yeah, so did you discover something that, for example, is gonna let some countries take advantage of that and that other countries will not be able to take advantage because of some regulations? Do you already have insights?
No, I don't expect that. So we are all governed by the same rules in this area, but there are local tastes to it, I think. I don't think that anyone will benefit more than anyone else. I don't expect it.
Mm-hmm.
But it's really important to notice and actually also to inform the people that are going to upload slides, because many instances people in pathology labs are also not experts and they often don't know exactly what counts for them. Right? It's a very complicated landscape. So any help that we can give people is of course very important.
So maybe one thing we did not mention is who was the instigator of this. And I think,
Yes, I want to know that. Who started this?
yeah, Pierre Moulin is the one who made the proposal. So it came from his idea. And I remember several years ago we had the same proposal and it was not accepted. So it looks like we were not yet ready. But when he asked for it, I think what year was it? Year one, 2018, when everything started, or 19?
19,
Then, yeah, 2019. Then people were ready. It's funny to see. Sometimes people are just ahead of their time, and
Yeah, totally.
I
And
think the European Union was not yet ready for digital pathology, but now they are. So here we come.
so I have a question because many of the members of the consortium are international pharma companies. How does that work? Because it's a European consortium, European project, but are you going to be collecting slides from overseas as well? How is that solved?
Yeah, most of the slides are coming from partners that are in Europe, but several partners, for example, Novartis, also have counterparts in the US. Some of the slides might come from the US, and also we have some of the help, for example, the computational pathology group that are helping scientists and things like that might come also from the US. But it's better for IMI projects to have most of the contributions that is in the Europe.
And once it's done, after the 6 years, can then people from the rest of the world apply and use this data as well, or it's also more Europe restricted? Because I imagine the maintenance of such a huge endeavor and this infrastructure is going to cost money. How is it going to be financed? Now it's a grant, I assume, that there has been some money that was allocated to this. It's going to be forever, or at least the maintenance is supposed to be long term. How is it going to be financed? And is there going to be some like maintenance fees? How do you envision that it's going to happen? And for Europeans and for people from outside Europe?
I would think that, of course, we will not restrict it to Europe because we will face the same problems all over the world. I think everyone would benefit if it's much bigger than Europe. And I think also, as you say, I think it's an important question, of course, how do you sustain such a thing? We have a work package, as Julie said, dedicated to that. So there's one work package that started already on day one to think about ways to make money, or not to make money, but to, let's say, to acquire money to keep this alive. They're actively looking into this. We can think about even having spin-off companies of the BigPicture project. And there are many different ways, of course, of getting the funds to keep this alive. And the bigger it is and the more, let's say, countries participate or the more people participate, the bigger chance that we will be able to sustain. And I think we do not really have the solution at this point. That we can't say what it is, and probably there will be.
You have another 5 years to come up with
Yeah,
it.
luckily we do.
But I'm super curious.
Plan is due in 3 years.
Okay.
Yeah, year 3 already, we need to have a plan in place and start to put it in place. So in year 6, it's up and running.
Okay. And do you also have either in your work packages or in the design of the project some way to adapt to new technologies, which we probably don't yet know what it's going to be? I don't know, maybe some more efficient ways of storing data, more efficient ways of maneuvering data. Is there somebody overseeing that? If it even is possible to oversee something that we don't really know what it's going to be.
Sounds complicated too.
It's a great question.
Yeah. It's good to realize that the repository is based on existing technology. So the EGA, is genomics archive, has been in existence for quite some time. And we are, say, adapting that technology for our infrastructure. The infrastructure, so basically what we are developing is a software layer, and the underlying technology probably can change. So, for instance, we would have different ways of storing our data. That's still the software that would keep track of that and take care of that can probably remain the same or has to be adapted. But of course, the underlying hardware, for instance, could change. It's all open source. Everyone could benefit from it, and also everyone could contribute to it at some point. But of course, it's not easy to take things into account that we don't know yet. We try to be very adaptable, very open, but I think, there's more that we can do.
So you say it's open source. The tools that you're building are going to be open source. How do you manage to have the open source and community and open to everyone component with legal compliance and regulations different in different countries? And another thing is regulating access to this. Is it something that somebody can take wherever they are and not let you know that they're using it? Or is there going to be a process to access it and to benefit from this?
So there will be a process. So this is defined by what we call the honest broker mechanism. So they will be the one doing the regulation of who is putting data in and who is taking data out, and or who is putting algorithm in or who is taking algorithm out. Because as we had said earlier, they coexist together on the repository. In a nutshell, there will be what we call a data access committee. So they will be the one deciding who has access or not, depending on the case that you will provide. So for example, Alexandra, you would like to do a model to detect centrilobular hypertrophy in rat liver. So you will write a little graph, you will submit it, and then they will revise it, make sure that you are legitimate, you are not an impostor, and then they will provide you with access to the data that you need to be able to have your objective that is fulfilled.
So basically like an application process to whoever is going to be taking care of this. Okay.
Yes. And we need to make sure that this is not too cumbersome also, as we want this to be open, being secure, but not too cumbersome. So we don't want it to take 6 months before you are granted access, because we want to be a catalyst, not a brake to development.
I asked the exact same question that you just asked, even before we started the project, to one of the people in the infrastructure group. And I said, how is it possible to have open source software and still know that it's secure? It feels as if there is a contradiction there. And he said, well, basically, because it's open source, everyone in the world can try to hack it and can have a look at it. And all the vulnerabilities will just come out because so many people have access to it. Yeah, and he gave the example of Linux, which is completely open source and is used by many companies for their server software. So actually, having it open source means that so many people can have a look at it and try to find weaknesses in it. That actually it's the best guarantee to get very strong, secure software. It feels like a contradiction, but it's actually a very good way of doing it, I think.
No, totally, like self-improvement of a product because the users can contribute to improving it.
Yeah.
This is amazing. So, guys, another question. Where are you going to have all those slides? And now the discussion is for every organization that is going digital. Oh, what are we doing with the slides? Hard drives is not an option. Can we have a big server? Can we have cloud? AWS? Like, where are they going to be? This is going to be a huge amount of data, if you can say. I don't know. Maybe
it's a good question. So we have
but it's an open project, so I'm asking those questions.
Yeah, sure.
So there will be two servers. They will be mirrored. So to make sure that it's a kind of security and a recovery security if something happens to one of the two. And there will be one in Finland and one in Sweden.
So the basic setup is that we will have 2 copies of all the data, as Julie said. But the repository will be built, the technology will be such that it can also be a federated system. So in the future, we could also have nodes that keep their own data, but are still connected to BigPicture and are accessible through BigPicture. And if I'm correct, I think in Finland, they have really a huge bunker in which they will store all the data. In Sweden, it's a local cloud solution. But so there's slightly different technologies behind it. But luckily, we have people that take care of that, and we don't have to buy the hard disks ourselves.
Yeah, you would have to buy a lot of hard drives. No, that's obviously not an option, but I'm just fascinated because it is like people think, oh, digital, not physical anymore, but at some point it becomes physical because you are storing this digital information on hardware. And this hardware has to get bigger and, I don't know, larger, more secure, double because you want a backup because it's digital. It can disappear. You don't want it to disappear. So, no, totally crazy initiative. And that leads me to another question. So, there are many packages, 6 years, many people involved, but you all have your other jobs. How are you managing this project on a daily basis? Because do you have people that are full-time employed by this consortium and by EMI, or you guys work for your jobs? So how does it happen?
For myself, I probably pass 30% of my time on the IMI BigPicture. And in Novartis, because we are involved in a lot of different IMI projects, there are people that their job is just IMI.
Just to do that. Okay.
Yes. And we have some FPA partners that have, for example, some FTEs that are dedicated to IMI as well. And some are just for IMI BigPicture.
We have a company, BigPicture, that is a professional project management company. So they have a few people, probably not completely full-time, but really dedicated people that spend a lot of their time on managing the project. And in addition, we have a lot of people with different partners that spend either their entire time or part of their time on this. So we have, for instance, a communication manager, someone that works 1.5 days a week just for communication. So yeah, we have a lot of people. It's as Judy said, it's a 32 million euro funded project. So we have a lot of people that work for the project.
And does the funding come partially from the members of the consortium and partially from the European Union, or how does that work? So Julie, who's paying for your 30%?
So usually the IMI project, the way they are funded, half of it is coming from the pharmaceuticals and the other half is coming from the European Commission. So it's a kind of, they are matching, the European Commission will match the amount of in-kind contribution that the pharmaceutical will be providing. So our in-kind for IMI BigPicture is in terms of slides and also people working on the project. And then up to 35 million. And then 35 million was provided by the European Commission to pay for the private partners that are involved in the project. So the 36 other partners involved in the project.
And how does that work for academia?
Yeah, so we get funded. So different parties have different roles in the project, which has been defined up front. Every party is, for instance, responsible for certain deliverables, for certain tasks. And we get funded, so we get different amounts for hiring people. For instance, I myself, I am funded 1 day a week for this project. And next to that, we have a budget for...
Do you only work 1 day a week, or do you work more than that?
I work 1 day a week for BigPicture officially. Of course, I don't track the time that, but officially I'm paid for 1 day a week for BigPicture. And next to that, we have a budget for slides. Partners providing slides can get reimbursed for the costs they make. So they may have to scan. They may have to hire people to upload slides, to find metadata. So we have some budget for that.
Okay, so at the moment we said we're 15 months in. Let's say it's end of the planning, end of the organization, a little bit of proof of concepts on different aspects. What do you expect to have done by next year? Because I'm gonna invite you again next year and we're gonna be talking, okay, what did you do, guys? What did go well? What didn't go so well? What's the plan to have accomplished by month 24?
So we have a big milestone coming up, which is the first clinical data that will be put in the database. This is one of the big milestones that it is coming up, the tangible milestone, because we have performed a lot of things in the first year, but it's not the things that people see. It's a little bit like when you are doing renovation and there are a lot of things you do behind the walls, but nobody sees it. So this is the first real data in the real database, not in the pilot. So we will be learning a lot from that. And at month 30 is when the non-clinical are uploading the data. The clinical group are our guinea pigs, and us, we will be the second in line, which is great because then they will have paved the way. So it's going to be way easier for us. So this is coming for month 30.
Okay, this is exciting. So I'm going to be inviting you next time when this milestone is met, or maybe before that. Thank you so much for taking this time and explaining this. I think as the project evolves, it's going to be maybe clear and more tangible, like you say, Julie, for people to understand, okay, what's happening? There is software, there is slides, there is access, there is like so many things. So I'm super curious how it's going to evolve. And thank you so much for joining me today.
Thank you. I think you will need to re-invite us probably.
I will. No worries. No worries. You have the invite for next year. No problem.
Thanks for listening. For more great digital pathology resources, visit the Digital Pathology Place website and subscribe to our newsletter on digitalpathologyplace.com. After subscribing, you will get access to the free digital pathology crash course, which will help you start working on your digital pathology projects immediately. Talk to you in the next episode.